Okay, welcome back everybody. Today what we're going to do is switch gears just a little bit, and we're going to go to finding LCD or LCM of rational expressions. Okay, we're not going to do any solving necessarily. We're not going to do any adding or subtracting of rational expressions. We're just going to focus primarily on the least common denominator, or sometimes it's called least common multiple, depends on the context that it's being used in. Okay, so let's go ahead and get started here on example 1, and I'm just experimenting here. Let me know in comments or whatever if this is irritating to you. But I just want to experiment with using a black background. I know that when I read, and I think my kids are the same way too, when I'm reading online, if I'm using my Kindle, or sometimes I use my iPad, I download books to my iPad, but if I'm using that, I tend to prefer reading with a black background. I don't know if it's the way you do it, but that's my preferred way to do it. But of course, if this is totally irritating to you, just let me know and I'll switch it off. But I'm just going to experiment with it for right now. So example 1, let's go ahead and we're going to find the LCM, which stands for least common multiple. And let's get down to business here. So we're going to find the least common multiple of 15m squared and 18mb squared. Okay, so let's focus in on, let's not worry about those exponents yet. Let's focus in on those coefficients for right now. So we've got 15 and we have 18. All right, so there's a couple different ways that you guys can find least common multiple or least common denominator. One way, which I don't think everyone's favorite way, is to just start listing them out. Just start listing out the multiples of 15. So you got 15, 30, 45, 60, 75, 90, 105, 120, 135, 150, etc. And then list off the multiples of 18 as well. So you got 18, you have 36, you have 54, 72, 90, 108. And if you're probably wondering, yeah, we already ran into it, right? There it is. It's 90. Right there, we just used that listing method. That's one way to do it. Another way to do it, I don't know if I've showed you guys this during the school year, but another way to do it is to use these things called division ladders. Maybe you've seen it in previous classes as well. But division ladders is where I have students that call it upside down division. It's where you set up the factors 15 and 18, and what you do is you think of a number, or you have to think of a number. It's not like you're thinking of a random number, but it has to be a number that can divide into both 15 and 18, and you want to avoid using 1 if you can. So sometimes you have to use 1, but let's say we can think of another number besides 1. And if you're going to think of a number that works, you want to put that number right there. And that's going to be the number you're going to divide by. Let's say we're going to use 3 because 3 does go into 15 and 3 does divide into 18. You're going to do the division. 15 divided by 3 is 5. 18 divided by 3 is 6. So you got 5 and 6 right there. And then what you do at this point right here is, if you can keep dividing, keep dividing. But there's nothing that goes into 5 and 6 besides 1. So if I put a 1 here, you'll see what happens here. I'm going to end up with 5 and 6 again. And I can keep using 1 over and over again, and it doesn't really get us anywhere. So what I'm going to do is I'm going to recognize the fact that I can stop at that point right there. And what you do is you make an L around the numbers that are on the side. And now in this case, we only have one number on the side and the numbers on the bottom. And the reason I kind of like this method is because the L is going to represent the LCM, or LCD if we're looking at denominators. But the L is going to be the LCM, which are all the numbers in that L. So 3 times 5 times 6, and you're multiplying them, by the way. So 3 times 5 is 15, and 15 times 6 is 90, and that's what we got up above. I think it's a nice little way to do it, and it works. It definitely works. I kind of faintly remember doing something with LCM earlier in the school year with you, way back in the fall. Maybe I didn't show you this. Could have been for something completely different. Also, it could be for the other class too, because I know I teach LCM for the non-fast-paced classes. Anyhow, that's what we got. So we got 90. Now we can all agree that 90 is our LCD for our coefficients at least, because we had 15 and we had 18. Now here's where it gets a little bit weird. So I'm going to write LCM equals 90. When you're looking at exponents don't have to be common. You don't have to have common bases. One way to kind of put it is that you're going to use so kind of here's the weird part about least common multiples, especially when it comes to algebra. But when you find the highest power, or when you're finding the least common multiple, you're going to use the highest power of everything. So the highest power of the m's is m squared. I know it's kind of weird because the L in LCM stands for least, but I'll kind of explain that in just a second. But we're going to use the m squared. For the b's, we've got a b cubed and we have a b squared. So we're going to use the highest power of everything. So there you have it. And the way you want to kind of think of this, and I know it's not the easiest way to do it, but the way you want to think of this is just think, okay, think to this LCM now. We've got 90m squared b cubed. That's what we have now figured out is the LCM. We've determined, and that is correct, by the way, 90m squared b cubed. Now, what you want to do is you want to look at that and go, okay, look at the original numbers, and does everything in the original number, does that divide into the LCM? Can you divide that into 90m squared b cubed? And that's true, you can. Let's go like number by number. Does 15 divide into 90? Well, of course it does. 15 times 6. All right? Let me just kind of clean this up. This got really messy. Does m squared divide into m itself? Of course it does. Does b cubed divide into b cubed? Of course it does. And then same thing over here. Does 18 divide into 90? Yep, 18 times 5. Does m, and I know that doesn't have a power, but that's m to the first. Does m to the first divide into m to the second? Yeah. If you multiply m times m, you're going to get m squared. And does b squared divide into, I know it doesn't go into it evenly, but can it divide? Can b squared divide into b cubed? And that would be yes as well. So you can see why we use the largest power of everything, because you want to be able to divide by those original numbers. So each original factor can divide into 90m squared b cubed. 15 divides. M squared goes into m squared. B cubed goes into b cubed. 18 divides into 90 evenly. M divides into m squared. B squared can divide into b cubed. So everything can go into it. That's how you know. So it's kind of weird. I know the L stands for least common multiple and you're using the largest one, but that's it. So that first example, I know we spent a lot of time on that one, but that really kind of teaches the fundamentals there of finding LCM. Okay, for example 2, it says find the LCM of 12x squared y to the 5th, and then 10x cubed, and that's a t right there, okay? So I'll talk about that in just a moment. So find the LCM. Let's focus on those coefficients right now, which is 12 and 10. So we can follow that listing method if you wanted to start listing off the multiples of 12. That's fine. Or if you can just do it in your head, which I'm sure a lot of you guys can do. So you got your 12s right there, and I just listed about a bunch. If you need more, go ahead and list more, but you probably already know what it is. And here comes a tough task, which is doing your 10s. I always have to look at a calculator for this. So you got 10, 20, it's 30, 40, 50, 60, 70, 80, etc. So you can see right now that the LCM of at least the coefficients is going to be 60 right there. All right, so we got 60. Now remember, we're going to take, when we find the LCM of the powers, you're going to take the largest power of everything. It doesn't even matter if it's common. And you're going to see what I mean here in just a second. But x squared, and we have an x cubed. So we're going to take the largest of those two. So the largest of those two is going to be x cubed. Now look at the y here. So we have y to the fifth. Now notice, there's no y over here. There's no y. There really is. I mean, if you really think about it, there's a y power over here. And you can imagine that it has y to the 0, right? Because what does y to the 0 equal? What does anything to the 0 power equal? It equals 1. So you can kind of put any letter you want to there if you want to imagine it that way. But there's a y over there. But in other words, there isn't a y there. So what you want to do is, again, we're going to follow that rule of we're going to use the highest power of everything. So the highest power of y to the fifth is the only power of y to the fifth, which is y to the fifth. There's no other y's. And the same thing is going to apply for that t factor right there, t to the fourth. There's no other t's. So you have to put that down. I know that, again, the c in LCM stands for common. And it may seem like, well, t is not common. There's no t in the other term. And if you use your imagination, there is. It's t to the 0. So you're going to, and this kind of goes against all of our basic math instincts right here. But remember, can each one of these factors, can 12x squared, just think about it, can 12x squared divide into, or I should say 12x squared y to the fifth, can that divide into our LCM? And sure it can. 12 goes into 60, x squared goes into x cubed, y to the fifth goes into itself. All right, so that checks off. Does 10x cubed t to the fourth divide into it? Yeah, it sure does. 10 divides into 60, x cubed divides into itself, and t to the fourth also divides into itself. So notice, each one of those are divisible into the LCM. Even though there wasn't a y common to both terms and there wasn't a t common to both terms, at least visually. So that's your LCM for that one right there. So this is a little bit bizarro. I know it's a little bit weird when you do these, but you just gotta practice a few and you'll get the hang of it. All right, now example 3, don't be too thrown off by this one. This one is just in fraction or rational number format. But it says find the LCD, least common denominator. Now finding the least common denominator is really the same thing as finding the least common multiple. We're just going to find the least common multiple of the denominators. Don't even worry about what the numerators are right now. Just let's focus on those denominators. Let's just focus in on those. It really doesn't even matter what is in the numerator for right now. I mean, it's going to eventually matter when we start working these out. But we're just going to focus on those denominators for right now. Now, since we're finding an LCD, let's go ahead and write it so that it's a denominator. Okay, so let's focus in on those coefficients first. We have an 8 and we have a 5. And now I bet a lot of you guys can do it in your head. 8 and 5, the LCD is going to be 40. So coefficient-wise, the LCD is 40. Now looking at the exponents, we're going to take the highest power of everything. Now notice there's not a ton of stuff here common. Is A common to everything? No. There's no A over here. Is there a C common? No. They actually, when you look at all the exponents, they don't share anything. So we're going to basically have to list everything. So A to the fourth, C squared, F cubed, H to the fourth. I didn't give myself a ton of room there. Now that's kind of an obnoxious example right there. that is your LCD for everything that we found there. So you can see now in this example, in this context right here, it's written in fraction form. And a fraction, remember, is a division problem. And the denominator is what you divide by. You divide by the denominator. It's essentially your divisor, right? And can you divide 8 into 40? Yeah, you can. Can you divide 8 to the 4th into all that? Yeah. Everything divides into everything. Never mind the fact that not everything's common. And that's so weird. I know that's the weirdest part about LCD or LCM, is that there's not an A common to everything. There's not a C common, but we still have to use it. And on this last example, I'm just going to leave this up to you to find the LCD. And this is a good point for you to pause the video and just see if you're doing this okay on your own. And I didn't give you too tricky of an example here to work on. So pause the video at any time and then just hit play when you're ready. Okay, so for the coefficients, I got a LCD of 18, and I know I wrote down an obnoxious number of multiples there, and you could have done that in your head. I just wrote them out just for fun. And so you got 18 as the LCM for the numbers, for the coefficients. And then when it comes to the powers, we're going to take the highest power of everything. So what's the highest power of x? Well, we have an x cubed and we have an x squared. So you're going to take the highest power there, which is going to be x cubed. And you're going to take the highest power of everything, even though there's not a y over in the other expression, you're still going to use it. So I'm going to put y to the 5th over here and y to the 5th there. Now don't worry about what all this is. I'd like to at least get going on this before the end of the year, before you guys close off the year next Friday on this, but that is right now, that is not important for us right now. We're going to get to that. For right now, this is the important part, is figuring out this denominator. That's going to be where all the heavy lifting is going to be involved for you guys, just getting the right common denominator, the least common denominator. All right, so hopefully this wasn't too difficult. I know algebra is tough, and it's tough enough doing e-learning and doing all that, but hopefully you guys understood this LCM business. And again, we were just talking about, for today, we were just talking about monomials. The LCMs can get a lot more complicated, and I'll show you that too. But for right now, let's just work on monomials. So your homework is to do the other sheet, the other part of the sheet, and just turn that in on your Google Classroom. And just like you guys did on the last one, just turn it in any format, whether you take a picture of it or if you want to write on your Google form using a computer and you want to, that's fine too. I can understand some of you are pretty good with that. Go ahead and do that. Or if you want to just write it on a piece of scratch paper and take a picture of that, that's good too. So I don't care how you turn it in, just make sure you guys practice it, okay? So that does it, everybody. Everybody have a great day. And you know what? It's a 3-day weekend as well. So everyone have a great weekend and Memorial Day off as well. All right. See you guys later. Take care.